Here's an example in which they give us a triangle and an angle theta, and they're telling us A is 2, B is 3. Let me put that information in. A is 2, B is 3. And they want me to find the cosine of theta over 2. I'll write this so it looks a little better for you. It's theta over 2. And this is sine of theta over 2. And this is tangent of theta over 2. So, and this is regular theta here. So this is all about half angle ideas, isn't it? Right? Because this is regular theta. They want me, and they're giving me a triangle in which I've got regular theta, and they want me to somehow find the cosine of theta over 2, sine of theta over 2, and tangent of theta over 2, half of theta. How do I do that? Well, I got to go to the formulas. So let's do that. So I go to the formula sheet down here. Let's start with, what did they say, cosine first? Yeah, cosine, then sine, then tangent. So cosine. So here are the half angle formulas. What's the cosine of x over 2? There it is. Plus or minus 1 plus the square root of 1 plus cos x over 2. Let's go write that down and use that. So right over here, the cosine of this one, cosine of theta over 2, is plus or minus the square root of 1 plus the cos of theta all over 2. Okay, now, what's with the plus or minus first off? Well, notice this is an acute angle. Theta, this says theta, is an acute angle, meaning it's less than 90. Clearly, because this angle has 90 right here. This angle is lower, smaller opening. This opening here is a smaller opening than 90 degrees. So it's less than 90 degrees. So theta over 2 is certainly, if theta is less than 90, then theta over 2, cut it in half, right? Theta over 2 is half as big as theta. That's certainly less than 90. In fact, it's got to be less than 45 even, right? If you divide both sides of this by 2, this has actually got to be less than 45. Okay, great, so what? Well, that means the cosine of theta over 2 is an angle less than 45 degrees. Okay, again, so what? Well, if you look at the axis system, remember the all students take calculus. If we're less than 45 degrees, then we're in here. There's a 45. We're somewhere in there where all the trig functions are positive. So ours is positive. Cosine's going to be positive. Sine's going to be positive. Tangent's going to be positive. They're all going to be positive. How do I know? Because the angle theta over 2 that they're asking me to find must be less than 45 degrees, must be in the first quadrant where all trig functions are positive. How do we know? Because the original theta is less than 90, clearly, just by looking at it. And then you divide both sides by 2, so theta over 2 is less than 45. It's in the first quadrant. Okay, so now we just use this formula. Equals square roots plus 1 plus the cosine of theta. What's the cosine of theta? Well, you remember SOHCAHTOA, right? SOHCAHTOA tells cosine is adjacent over hypotenuse. This side right here is the opposite. This side is the adjacent, and this side is the hypotenuse. Ah. So, step 1, find the third side by the Pythag, a squared plus b squared is c squared. So we've got 2 squared plus 3 squared is c. This is the hypotenuse c. So that's going to be 4 plus 9 is c squared, 13 is c squared, root it. C is the root of 13. So c up here is the root of 13. So now, cosine adjacent over hypotenuse. This is adjacent, this is hypotenuse. Must be 2 over root 13. Right? All over 2. You tracking with me? Cosine of theta there is 2 over root 13 because that's adjacent over hypotenuse. That's adjacent over hypotenuse. Okay, so now we have to simplify that. Somehow we've got to simplify that. What should we do to simplify that? Well, let me write a little note to be helpful. maybe down here. When we have fractions over fractions, with adding, subtracting. So if you have fractions over fractions and you have adding, subtracting, which we do here. We have adding and subtracting going on, right? Right here we got adding. So that adding and subtracting always makes things harder. What do you have to do? You have to multiply top and bottom, all the terms, by the LCD over 1. And the LCD equals 1 of each type of item under a small bar. So you got to look at the items that are under small bars. What am I talking about? Well, here's a small bar, root 13. Now, not this. This is a major bar. See how we have fractions? This whole thing's a fraction. We have fractions within fractions, right? So when you have that, you got to look at the thing under the small bar. That's the only thing under a small bar, root 13. So you got to multiply. That's the LCD. Everything by LCD over 1. So I've got to take this expression. Boy, it's getting messy. Let me bring it down here. This problem really takes a lot of room. So cosine theta over 2 plus or minus square root of 1 plus cos theta over 2. So that's going to be plus. We decided it's plus. They're all plus because they're in the first quadrant. 1 plus, and the cosine of theta was root 13. No, it was not. It was something different. What was it? 2 over root 13. 2 over root 13. Okay, now how do we handle this? We're going to multiply LCD over 1. So I'm going to go root 13 over 1 right there. And root 13 over 1 right there. And root 13 over 1 right there. So this will be plus the square root. This will be root 13, right? Root 13 times 1. That 1 on the bottom isn't doing anything. Plus, these guys cancel. Just 2 on the bottom. 2 times root 13. And that's it. We'll just leave it like that. Don't worry about those extra roots. You might think, well, first off, did you understand that? Is that good? Root 13 times 1. If you can, I'm just not writing very neatly there. I don't like that. That's a root 13 over 1 multiplying the 1 that was already there, right? And so that's just root 13. And here the root 13s cancel. It's just 2. The bottom is just 2 times root 13. Again, these 1s here, doesn't matter. Get rid of them. So there we go. That's our answer. We leave it just like that. You don't need to get rid of anything. In fact, you can't. You might think, well, shouldn't we cancel those root 13s? It's actually illegal. You cannot do that. You cannot cancel items added or subtracted. I call it Costco glue. If you remember some of my other lectures. So this plus sign right there is gluing those things together. The root 13 on the bottom can totally, he doesn't have a problem. He's just times. He's ready to cancel. But the one on the top is like, no way, I'm glued to that 2. If you cancel the 13, you got to cancel the 2. They go together like shopping at Costco. Everything's a package deal. You buy both the milks that are glued together or none. You can't say, I just want this one, thank you. You can't do it. So that's what pluses, adding and subtracting is like in algebra. They're glued together. Cannot cancel items. You can't cancel just one of them. You have to, it's all or nothing. Must cancel both or nothing. Right? Package deal like shopping at Costco. Buy the whole package or buy nothing. Anyway, so we're done. That's it with the cosine of theta over 2. All right, let's do the other 2. It's a lot of work. And that was just the first one, but the other 2 are going to be the same thing. Sine theta over 2. Let's do it. So sine theta over 2. The formula, if you look down here at the formula sheet, sine theta over 2. There it is right there. Plus or minus, square root, 1 minus. Almost the same, just difference is that sign in the middle. right? Isn't that what it was? Yep. Okie dokie. Let's come on up here. Square root of 1 minus cos theta over 2. It's going to be plus. We've been through that. So it's plus the square root of 1 minus. And what was the cosine of theta? Well, again, getting back to our triangle, cosine of theta. Cosine is adjacent over hypotenuse. So it's adjacent over hypotenuse. It's 2 over root 13. That's the cosine of regular theta, right? Regular theta. We're finding the sine of theta over 2 in terms of the cosine of regular theta. Regular theta is the one in the triangle. So we get to that situation. What are we going to do? Same thing we did a minute ago, where we multiply by root 13, multiply by root 13. It's over 1, really. Multiply by root 13. These cancel. What do we get? Square root of root 13, right? Root 13 times 1 is just root 13 minus 2 over 2 root 13. There it is. Looks a lot like the other one, just has a different sign in the middle. There's the sine of theta over 2. It's the exact answer. And finally, tangent, right? Don't they want tangent? Tangent of theta over 2. All right, let's do it. Let's go get the formula. Half angle formula. Okay. I think you'll find there's a bunch of them here. Tangent of x will do. There's this one. That's a hard one. This one's a lot easier, or that one. I would use these two almost all the time. So I'm going to use this one. Sine over 1 plus cosine. You don't have to mess with the plus or minus. It's kind of nice. Sine over 1 plus cosine. So I'm going to do that one. Sine over 1 plus cosine. Sine over 1 plus cosine. Now, do you see the deal? Tangent of theta over 2, half angle, is sine of the regular angle over 1 plus cosine regular angle. That's what it said, right? Tangent of x over 2 is sine of regular x over 1 plus cosine regular x. That's what these half angle formulas are. Half angles in terms of regular, half in terms of regular, half in terms of regular. All right, so back to it. So what's the sine of regular theta and the cosine of regular theta? Well, go find out. Back up here to my triangle. Here's my triangle. Here's regular theta. So I'm going to get sine, cosine, tangent, and stuff of regular theta from this triangle, aren't I? What does it say? What is sine is opposite over hypotenuse, so opposite over hypotenuse. 3 over root 13 for the sine of regular theta. 3 over root 13. So 3 over root 13 over 1 plus, and then what's cosine of regular theta? Go back again to the triangle, because that has the regular theta. Cosine, you know, is adjacent over hypotenuse, so adjacent over hypotenuse. 2 over root 13 is cosine. 2 over root 13. Whoop. Here we go. All right, how do we simplify this? You know, you got fractions over fractions. Multiply root 13 over 1. Root 13 over 1. Just do those two. No, also this guy. Common mistake is just to do those two. Remember, it's got to be all the terms. These cancel, these cancel. So where in the world does that leave us? Here on the top, we just have 3. On the bottom, we have root 13 times 1 is just root 13. Plus, and these canceled, 2. There it is. That's the final answer. We can leave it like that. We just leave the root on the bottom. That's good enough. Don't worry about it. That's plenty of work right there. So we found the sine, cosine, and tangent of the half angles using the formulas from the original triangle, which had the normal theta angle, led to the half angle values.